Hey guys, today we are going to discuss about candidate elimination algorithm. Before we get into the candidate elimination algorithm, we have to know the drawbacks of finder's algorithm. So in finder's algorithm, we consider only positive samples. So it is difficult to compute the negative samples. Here, candidate elimination algorithm came into existence. So we can also call it as the updated version of finder's algorithm. To compute the candidate elimination algorithm, we use version space. Version space is nothing but the intermediate space of both general hypothesis and specific hypothesis, which gives us the result of the sets of hypotheses. Here we have both specific and general hypothesis in this algorithm, where we will be computing them as specific hypothesis from the top and general hypothesis from the bottom. And we consider both positive and negative results, where positive means true and negative means false. For positive examples, we tend to generalize specific hypothesis, and for negative examples, we tend to make general hypothesis more specific. You will understand it more clearly when we are discussing the examples, so no need to worry if you have any doubts. So let's get into the next slide. It is algorithm. So firstly, you will be given a table which consists of attributes and results. To start the problem, you need to take specific hypothesis as S0 and general hypothesis as G0 as initial values, where those initial values will be represented as phi for specific hypothesis and question mark for general hypothesis. The number of values to be taken depends on the number of attributes given. For example, if you are given 3 attributes, then take 3 phi's for specific hypothesis and 3 question marks for general hypothesis. So guys, as we discussed before, we have both positive and negative results in candidate elimination algorithm. If we have positive result, then make the specific hypothesis more general, and if we have the negative result, then make general hypothesis more specific. Let us discuss an example for better understanding, guys. So in this example, we are given a table which consists of 3 attributes and the result column. So, and we have given here 5 cases. So firstly, what we have to do, we have to consider the initial values. We have 2, specific hypothesis on the top and the general hypothesis in the bottom. We have taken the 3 values of phi and question mark, as we are having 3 attributes. So guys, now we have to compare these values, phi with big. Is it a match? So sorry guys, I have to tell you an important thing here. Phi in specific hypothesis is unchangeable. That means you cannot exchange it with the other values, whereas the question mark in general hypothesis is replaceable. So you can replace it with other values also. So now let's get to the problem. So when we are comparing the phi with big, as the phi is unchangeable, the phi and big are 2 different values, so it is no match. And phi with black, it is also a no match. Phi with heels, it is also a no match. So the result here is no, and the result which is given in the table for case 1 is also no and no. So there is a match, right? So the S1 will become same as S0. So S1 will become same as S0. So when we are come to G1. Now we have to compare this question mark when compared with big. As the question mark is changeable, it is a match. So we are it is like a variable, so we can keep any value in this question mark. So question mark and big, it is a match. Question mark with black, it is a match. Question mark with heels, it is a match. The result for G0 is yes, but the result which is given in the table is no. As it is a no match, we have to change the G1 values. How we will be changed? We have to write the opposite values for the values which are given in the table. So it will become as G1 is equals to small question mark and question mark. What is opposite to the big, for which the values given in the table? Big and small. So the opposite of big is small. So we have written small here, and the first part is completed. We have two more parts, right? So it will become as question mark, brown and question mark, as the opposite of black is brown. And now let's get to the third attribute. It will become as question mark and flats, as it is the opposite of hills. Now this the case 1 is completed. Now let's get to the S2 part. When we are comparing this, phi and small, no match. Phi and black, no match. Phi and flats, no match. No, and the result given in the table is also no. What we have to do, as it is a match, we have to just write the same value for S2 also. So S2 will become as 5, 5, 5. And now let's talk about G2. What will G2 become? So let's compare this. Small and small, it is a match. Question mark and black, match. Question mark and hills, match. Here the result is yes, but the result which is given in the table is no. As it is no match, we have to exchange the values, means we have to write the opposite. So it will become as small. What is the opposite value of black? It is brown. So it will become as small, brown and question mark. Now to the third attribute, small, question mark and heels. The heels, which is the opposite of flats. Now let's get to the second bracket of G1. The first bracket is completed, guys. Now let's get to the second bracket. So question mark, brown and question mark. Is it a match? No. The result here is no, and the result given is no. It is a match. So let's write the same thing in G2 also. Now let's get to the third bracket, which is question mark and small, match. Question mark and black, match. Hills, flats and flats, match. Yes, but the result in the table is no. As they are no match, we have to exchange the values, and it will become as this. Okay, guys. Now let's get to the third case. If you see the table, the first two cases are no. So we started from the specific hypothesis. But when we get to the third case, the result is yes. When the result is yes, we have to first write the general hypothesis. So we have to write G3 first. So let's compare this. Small with small, match. Brown with black, no match. Question mark with hills, match. But the result here is no, and here yes. As they are no match, as it is a no match, we have to just eliminate this. Okay, guys. So just eliminate this. Let's get to the second bracket. Small, match. Question mark, match. Hills, match. Yes, and the result is also yes. So let's just write this for G3. Okay. Now the third bracket. Question mark and small, match. Brown, black, no match. Question mark, hills, match. But the result here is no, but the result in the table is yes. So what we have to do? We have to just cancel it. There is no need to exchange the values or write the same here. We have to just cancel this. Now let's get to the fourth bracket. Big, small, question mark, black, flats, hills, no, and the result is yes. So we have to just cancel it. Same as the fifth, it is a no match, so we have to just cancel it. The G3 is completed. The G3 value is same. Now let's get to the S3. So what happened here? When we are comparing S2 and these values, they are no match, right? 5 with small, 5 with black, 5 with hills, it is a no match. But the result is yes. So what we have to do? We have to just replace the 5 values with the values of attribute case 3, small, black and hills. Okay, guys. So next the result is no. So which we have to start with? The specific hypothesis. So S4 will become same, because small when compared with big it is a no match. Black when compared to brown, no match. Hills and hills match, but the result here is no, and the result given is also no. As they are same, we have to just rewrite that for the S4 also. Now let's get to the G3. Sorry guys. Okay. Now let's get to the G4. And now compare small with big. It is a no match. Question mark with brown, match. Hills and hills match, but the result here is no, and the result there is also no, so just write that. Okay, the G4 is small, question mark and hills. Now S4 and G4 is also completed. Now let's get to the fifth case, which is yes as a result. So when we are getting S as the result, we have to start general hypothesis first. So G5 will become what? Small match, question mark brown match, hills and hills match. So just rewrite that. Okay, now the S4 S5. Let's consider S4 with this small and small match, black and brown no match, hills and hills match. So as small and hills are a match, we have to just write these two similar, and while black and brown are a no match, you have to replace the black with question mark. So it will become like this. So guys, you see clearly S5 and G5 are same values, right? So this value is applicable for all the cases here. If you want to check, see, small and big no match, question mark and black no match, but the result here is no, and the result given is also no. And for the case 2, small and small match, black and question mark match, flats and hills no match, and the result given is also no. When we get to the fifth part, small and small match, question mark and black match, hills and hills match, and the result is also no. So it will be applicable for all the cases, guys. That's it guys. Thank you.